Okay, so let us start. In the previous class, we looked at things like, for those who didn't attend, we just basically looked at doc strings, looked at stuff. Oh, wait, I haven't shared my screen. Okay, so confirm you can see my screen.
Confirmed.
It is visible. Okay. So in the previous class, we looked at things like doc strings. We looked at how to write clean code. We looked at what else did we look at? We looked at scope. Yeah, we looked at scope within functions, local scope, global scope, such things. And today I wanted to introduce you to object-oriented programming. Okay, I wanted us to get used to this, get introduced to this part, which is very, very fundamental in programming. When you try to read through the history of programming languages, in the early languages, we had languages that were basically writing procedural code. So you're just basically writing procedures. They're telling the computer, do this, do that, do this, do that. Okay. But now, they later introduced a concept of object-oriented programming. And you've been hearing me all the time from the beginning of these sessions that everything in Python is an object, okay? Everything in Python is an object. Let it be a list, let it be a tuple, let it be a set, let it be a dictionary. Everything in Python is an object. And I have here, just look at this. So the rest we are going to be coding live. We're going to be coding. I don't have much pre-written code, but when you try to look at, for example, we have seen what the type function does from the beginning, where we use it to check for a data type of of whatever we have. So we see that here we had a list 1, 2, 3. We're checking for the type of, this is a tuple 1, 2, 3 also. Okay, we have a set here 1, 2, 3. We have a string. We have the none. We have a float here, which is 1.5. We have an integer. We have a boolean. Okay, and when you check all these, okay, don't try to write this code. This is just I'm giving you a bit of a background about what you're going to cover. So when we see things like this and you try to run this cell, it will tell you that this is a list. Yes, this is a tuple. We have seen that this is a set, this is a string, this is a none type. But we see that we have something called class. Okay. Now this is class, and it's going to be our focus of conversation today. Okay, it's going to shape our conversation today. Classes. But before we get into classes, allow me to talk to you about something very, very small, which we call a list comprehension. I wanted to bring it immediately after we did loops, but I couldn't introduce that at that time. So let me just get into my desktop and let me go to my desktop and create a small folder. Yeah, I'm just going to create a small folder. I'm going to name it just Python code. And Don't worry if you don't see my screen, but I'm just trying to open up my VS Code. Okay. So let me try to share my let me share my entire screen actually. Let me share my entire screen. So I believe you are now seeing my my VS Code. I'm in the folder called Python code. So I'm just going to create, I just created the folder randomly. So let me just create a small file called list comprehensions. For those who are using Jupyter, don't worry about saving it as a .py file. Just continue coding as usual. For those who are using VS Code, I know we are not familiar with the environment. So I want to talk about list comprehensions. Comprehensions, okay? So list comprehensions is just basically a faster way of creating lists, okay? So for example, let me try to create a list here. So if I have my list, for example, and it's an empty list, okay, we are going to create a list of items. I can create a list by using a for loop. So I can say maybe for character in A, okay, so for character in A, okay, so I can say my list dot, remember the dot append method, okay. If you are in Jupyter, you're not going to get these suggestions, but if you are in VS Code, it will give you the suggestions of the methods available. So dot append, okay, what do we want to add to the list? It is the car, okay, the variable that we created here. We have looked at loops, okay. So now I can come and print out now my list, okay. And if I run this code, I'm gonna get a list with A, right? We're going to see each character added to the list, okay? But there is actually a faster way of creating this list, and this is what we call the list comprehension. So I'm going to basically keep this code, okay? But let me try to create it with a second list. So let me say maybe my list 2, right? My list 2. What you can do here is define your variable as usual, like how we did here, my list 2, and open those square brackets because you want to create a list. And now we are going to have something like this, okay? Character for character in, okay? So character for character in, let's have the same A, right? Now, let me try to run that. You see that, let's print it out. We have not printed out my list 2. So if we try to print out my list 2, we see that we now have 2 lists, okay? We have 2 lists down here. There is the first list. Let me first comment out this code. Let me comment this code so that we can see properly. So if we try to run that code, we see the A down there, right? So something that we did here in 1, 2, 3, 4, 5 lines, here we just did it in 1 line, all right? And then printed out that list. So how cool is that? Let us try to also say, maybe we want to create a list that is full of numbers, okay? So I can say maybe my list 3, okay? My list 3, I can say now, let me try to break down this, what just happened here, okay? So the way I love to remember it is this, that when we have my list 2, for example, let me just copy this code again and just paste it here. I'm just going to explain. You don't need to copy it also. So this is a for loop as usual, okay? Just like how we saw for car in hey, right? So this is our normal for loop, okay? And the way I love to remember it is declare your variable first. Even you see that VS Code tells me that the variable is called car, okay? So create your variable, okay, first, all right? Create a variable and then run the for loop. Now, the variable, of course, also comes there in the for loop, right? And then you have your iterable, okay? You have an iterable there. So it is variable for variable in iterable, as simple as that. So you remember we said iterables are those data types that can basically, you can loop over and return every independent item within that data type. For example, a list, you can loop over a string, we can loop over a dictionary, we can loop over a set. We saw that when we were doing for loops, okay? So that is basically the structure of a loop comprehension, of a list comprehension. So it is a variable in iterable. So you don't need to be confused by this part. This is just basically the normal for loop that we had, and we have the character. This is the variable that we have defined. So let's say that we wanted to print out a list that is full of maybe numbers in a range of, let's say, 1 to 20. So we can say num, which is our variable, or you can say number. Again, now for number. Now we create our loop here, our for loop here. So for number for number, okay, in range. We saw the range function, okay? So the range function, so 1 to 20. So let us try to print out my list 3, okay? So if we try to print out my list 3, but my zoom controls are blocking my view. They're blocking my view, so let's say, sorry, it is my list 3 here. How do we hide these zoom controls? They are blocking my screen. Today I'm using one screen, so but let us just have them at the bottom as usual. So my list 3, and when I run that, you see that we get our list printed out, a list of digits from 1 to 20. But let's try to make it a bit more challenging. And maybe we say we want to print a list of numbers that are maybe multiplied by 2. So for example, here we want a 2, we want a 4, we want a 6, we want an 8, we want a 10, a 12, and so forth and so on. So if we wanted something like that, let's now say create a new list called my list 4 is equal to, open your square brackets because it's a list. Let's just copy this same exact code and copy it there. Now, what we need to do is simple, that now this is our variable here. Let us just multiply it by 2, right? And let's print out my list 4, right? So when I print out my list 4, right, we see we have our list 4, 2, 4, 6, 8. So what changed here is that in this place of a variable, now we have a whole expression, okay? So we put our expression here and did whatever we wanted to do with the variable before we created our list in the range of 1 to 20. So let's say now maybe we want to create a list.
Josh.
Yes.
We have a range of 1 to 20. How come when you print it returns numbers beyond 20? Because I see it's going all the way to 38.
We have multiplied every number that is in the range of 1 to 20 by 2. That's what this expression is doing. We have gotten each number, including 19, and multiplied it by 2. So you're going to have a list that is above, with digits above 20. Okay. So.
Okay, I get it.
Yes.
I get it.
So now I was saying, let's try to make it a little bit more challenging by saying that we want to create a list of maybe numbers within a list of between 1 and 20 multiplied by 2, but we want to return even numbers only. When we look at our list, we only have 8 even numbers because they're multiplied by 2, but let's maybe make it something like that, okay, which is going to return the squares. Okay, so when you run that, it's going to give us, some are not even numbers. So let us try to say we want to return this list, okay, but with numbers that are returned even, sorry. So what you can do is write the same code, all right? Let's store it in maybe my list 5, right? In my list 5, what we can do is disable. So my list here, we can do number. Let's just basically copy the same line of code here that we wanted. Paste it in there, and let's keep that the way it was. So we want this, but now what we can do is, after evaluating this function, all right, after evaluating this expression of ours, for example, let's run it again. They are getting too many, so let me try to comment these out so that we have something small. Okay, so we haven't printed it out yet, so let's print out my list 5, and my list 5 is, let us try to print it out. We see it there. We had already seen it with the squares. So what we can do is just add a small expression, an if statement here. We can just say if number modulo 2, okay, modulo returns the remainder, so equal to 0. Okay, so first get the number, square it, all right, for a number in the range of 1 to 20, but return only if the number divided by 2 returns a remainder of 0. So when we print out my list 5, it's going to do the same thing. So list comprehensions are basically a very, very easy way of trying to create lists in a very fast way than if you had written a whole for loop. So we just write this whole thing within one line. The same thing with the ternary operator that we saw in if functions, where you can just write an if function in one statement. So I hope that is clear. Hope that is clear. Let me go back to
hello, Doctor.
Yes.
Yes, I had a question. Why is that when you put my lists, for example, you put in a range of 1 to 20, it only gives 19? I thought that the 20 comes up as well.
Yes.
I don't know if I missed.
No, you didn't miss it. So what happens when you print 1 to 20, okay? So the easiest way to remember it is that the range function has a start, okay, and a stop -1. So just easily remember it that way, that whichever number you have written here that is the end, Python is going to subtract 1. So it's going to return everything from 1 to 19. Okay, I hope that is clear. So if we had 30, it is going to return everything up to 29. It's not going to consider the 30. So the easiest way to remember it is that the range has a start, it has a stop, -1. Okay, so the stop, which is 30, subtract 1, and then if you're returning a list between 1 to 30, you are going to get everything from 1 to 29. I hope that is clear on your end.
Yeah, it is.
Yes.
Doctor,
yes.
I just wanted to clarify
Mm.
on this last list printed that the if statement we have, if number module 2 is equal to 0.
Yes.
You said that it means that if the number, if you divide by 2, have a remainder of 0, right?
So the modulo operator returns a remainder. Okay.
Yes.
So
yes.
you remember operators. Okay.
Yeah.
So if we say 4 divided by 2, let us try to also print 4 divided by 2. Let us print 4 modulo 2. Okay. So when you print these out, it's going to give you the first one, which is a 4 divided by 2. We know that when you divide 4 by 2, you're going to get 2. But this is going to return a float, which is a 2.0. When you use a double slash sign, which is the divide, this is called flow division. Okay, it's called flow division. And this flow division is just going to basically return the integer 2. Okay. The modulo is going to divide 4 by 2, but it is going to bring the remainder. What remains after dividing 4 by 2? It is 2, remainder 0, isn't it?
0.
2, remainder 0. The modulo operator returns the remainder. And we know that even numbers, when you divide an even number by 2, it is going to have a remainder of 0. That is what this logic means. Okay. So yes, you can go back and try to revise your operators, because that's what basically that's what we are doing here, right? So yeah, now let us try to go to classes. So wanted to introduce that concept of OOP. I was trying to introduce OOP, but I remembered that I had missed out the part of list comprehensions, which you are bound to find in a lot of projects. So let me just say oop.py as a new file. Today, let me code within VS Code. So OOP, or object-oriented programming, as I had mentioned, is a paradigm. Okay, so it is a paradigm. Okay, so it is a paradigm which is basically saying that everything within our Python as a programming language is an object. Okay, so we're dealing with objects. So I was trying to show you that if you try to print out maybe the type of hello, we know that hello is a string, but when we try to run this, it is going to show you that my output, I want the terminal. So it's going to show you that it is a string, but we have this part which is called a class. Okay, so classes are basically these I could call them data types that help us to create our own. So let me try to show you something. You know that when we have a list, for example, let's say we have a list, maybe my list. Okay, have a list with 1, 2, 3. So we have seen things like if you can get my list, okay, and if you put a dot, okay, it will give you all these kinds of access to all the methods that are available. If you're in Jupyter, you might not see that, okay? In Jupyter, you might not see that, but in VS Code, you are able to see all this. Now, the person who wrote the list, for example, okay, who wrote for example, the code that is behind reversing a list, they wrote something that we are going to see in here. Now, let me delete this. And the classes in Python are defined by a keyword class, right? So you cannot have a variable called class, right? Because it's a keyword. And when you are defining classes, we can say maybe a big, let me call it maybe big object, okay? So big objects, and you will do that. So you'll notice that the naming convention has changed. We are using, this is called what they call Pascal case, okay? Call it Pascal case. When naming different things in programming, we have different ways of naming. So we had the snake case, for example, when you saw when you're using variables, okay, you use snake case, everything is in small letters really, and we even use these underscores, okay, so that is called snake case. We have another naming convention which they call camel case. So for example, if I say this, okay, maybe my list, so the first letter is a small letter, and the next the second word is in uppercase, okay, this is called camel case. But here we are using what they call Pascal case, right? So Pascal case is basically the naming that case that we use to name classes, right? So let me try to show you something here. I can have my class, I call it big object. I can have the code there, right? And I can say, let me just use pass. Pass is basically a keyword that we use to in functions, and these classes, you basically define a class and don't want to write code around it. So you just use the pass keyword, and the interpreter will skip onto the next line. So when I say class, big object, okay, this is our class. I can now say object, okay, object 1, for example, I say object 1 is equal to, okay, so what I'm doing here, I'm going to create an instance of a class. So I'm going to explain everything that I am doing here, right? So let me try to print out maybe object 1. So classes are what we call blueprints, okay? Blueprints, all right? So these blueprints are they are the master. If you understand what the meaning of a blueprint is, it is basically, let's say we have a person, okay? We can create a class of a person, but we know that a person has different features, all right? And a person can have features like a name, can have features like an age, can have features like maybe a job, okay? A job that they do. So a class is basically a blueprint that we use to define all those characteristics that are going to be part of the final object, okay? So when we have something like a class of big object, maybe let me try to explain it by saying, let me get a small picture here. Let me get a small picture here. We get a small picture. I have a small picture here. So let's say we want to code. We have been hired by a company, and it wants us to code a drone. Okay. So we look at a drone, for example. It has different parts. It has propellers. It has this part that holds, it's called maybe the gripper, okay, that holds the package. And it has features like cameras. It has features like the antenna that helps you to send signals to the antenna, to the drone, and also from the drone to your device. So when we have something like this, it helps us in a way that the developers, we can have one developer, we can have Flavia code out the camera, okay? We can have Provia code out the propeller, okay? We can also have another developer, okay, code out this part, which is the gripper, and we can have another person code out this antenna, okay, that is going to help you send signals, okay? So, but the whole blueprint of the drone is, we know it has all these parts, right? And when we are defining everything here, is we define everything according to that blueprint. So when we have class big object, okay, we shall write code under our classes. But let us, for example, say we have object one dot big object, okay? Oh yeah, sorry, I forgot to put that. And when you say print object one, when we print it out, it tells us something here, that this is, first ignore this for now. We shall look at what this means, but this is a big object at a random. Now this is a random space in memory. So what Python is doing is that this is a class, and we have created an instance of an object. Let me try to show you what we are talking about. Let's use the same example of a drone, for example. So we can have class drone, okay? Maybe let's call it a delivery drone. Delivery drone, okay? Notice the naming convention there, okay? Remember, in functions, we would put these brackets, but here we do not, okay? These are classes. Now, when we create a class, delivery drone, I'm going to write some code quickly, and then I'm going to explain what I'm basically doing, okay? So I'm going to do that. Self, a drone has a camera, a drone has maybe a propeller, a drone, okay, let's just keep it at that, okay? So I say self dot camera is equal to camera. I say self dot propeller is equal to propeller. Did I write this right? It's propeller. Okay. So dot propeller is that. So let us just try to define a method here. Maybe fly. Let's say maybe something like fly. I say self, and I print I can fly, something like that. Okay. So let me continue writing more code so that it will make sense to us. So we have drone one. It is going to be equal to delivery drone. Okay. So let's get to that part, and let's try maybe to print out drone one. So now this is what we have done. If I print this, of course, it's going to give me an error. It's going to tell me that I am missing two required positional arguments, camera and propeller. So I can put here my camera. I say maybe it's an HD camera, and I can say maybe 4 propellers. So when I print out drone 1, it's going to give me the location in memory, like we were seeing. I'm sorry if I'm moving this, but my screen is limited due to the zoom controls that are at the bottom of my screen. So print 1 dot, you see, I get access to these things, but when I say dot camera, I'm told that it is HD. If I print out something like dot, you have dot propeller, I get something like 4 propellers. So let me explain what just happened, okay? So what we have here is a class of a delivery drone, okay? So we have a class of a delivery drone. When we create that class, we saw that a class has, the drone has a camera, has a propeller, okay? But we see that we have this part here called the self keyword, okay? We have the self keyword, and we see we have something like self.camera, we have self.propeller. Now, when we create a class, this first part is what we call a constructor method, okay? This is what we call a constructor method. Let me comment it out so that it doesn't throw an error. This is what we call a constructor method. And we have seen such methods before that have a double underscore with them and also a double underscore at the end. And we said in the previous class that this is what we call a danda method, okay? Or a magic method. Now, this is the point where we have a conversation about that because they are really, really, really useful, okay? So this is what we call a danda method. Now, this is basically, we're initializing, okay? We're initializing our constructor. And this self keyword, okay? This self keyword is basically called every time. We call this part every time an instance of a class is called. This is what we call instantiation, okay? We have created an instance of the class drone 1. We say the drone has different parts, the different characteristics of a drone. We define them here. We say self. Now, this self keyword, I'm going to explain what it does. But when we have these parameters that we passed into this function, in this constructor method, we say that a method, a function in a class is called a method. So do not worry when you hear me say things like this is a method, this is a method, okay? If it is alone outside there with its def keyword, it is a function. But if it is under the class, it is called a method. So mind the language. So now we have self.camera, okay, which is camera, and self.propeller to be equal to propeller. These are what we call attributes, okay? These are attributes of the drone, okay? The drone has an attribute called a camera. The drone has an attribute called a propeller, okay? The drone has an attribute, what we call maybe the gripper or the clipper or something like that. So these are attributes of the class delivery drone. Remember, we said a class is merely a blueprint. Don't forget that it is merely a blueprint. So it helps us define all these attributes of an object. Now, where is the actual object? The object is down here. We have created an instance of delivery drone, and we have given it HD, which standing for the camera. We have seen propeller to stand in for propellers, to stand in for propeller. But where is this self? Because You remember when we were talking about functions, we said when you pass in three parameters, you have to pass in also three arguments. If you pass in two parameters, you have to put in two arguments. But here we see that we have three, but we are saying this. Now, this is the explanation, and this is the best way I can explain it. So when we try to look at something like a list, okay? So a list, when you have an empty list and we say dot, we see that we have access to all these different methods that are attributed to that list, okay? Now, we can create very many lists with different names, okay? We can create my list 1, my list 2, my list 3, up to my list 100. I can create a list of emails and call it maybe email list. I can create a list of maybe names. I call it name list. But at the end of the day, the list you have created will still have access to the same method, okay? So the person who wrote the code behind a list created a blueprint of this list. Let's see what that is actually. So I can say maybe, for example, we haven't seen this function before, but when I say help list, okay, I can get, let me, this is in VS Code, it's going to look very, very small, but let me try to run it within maybe, let me try to run it within here, okay? So if I say help list and I run it, I'm going to get the entire blueprint of what is behind a list. And we can see that methods that are defined in the list, we have add, okay? It has contains, it has delete item, it has, these are other methods that we didn't see, but we have, to try to continue, you have the length method. You remember we have a length method. You can check for the length of the list. We have things like append. We have seen append, and it tells you that this appends an object to the end of the list. Clear, all that, okay? So we have extend. Now, that is what is behind the code of a list. But also us, in the same manner, if we are creating a list, creating a class, a blueprint, you are creating this self keyword here, basically is saying that you help me to name the item or name the object that has not been created yet. Remember, going back to the example of the list, the person who wrote the code of the list does not know that you will create in the future, that you will also create a list maybe and call it my list, or create a list and name it email list, or create name list, okay? So he does not know what name you'll give to your list. So this self keyword is basically, I can call it a placeholder, okay? It is standing in for that self. The self is standing in for that object that you are going to create. So for example, if when we are writing our code delivery drone, we do not know that at one day we shall create a drone object and call it drone 1. But we can even call it drone 100, okay? Because you're going to keep on creating these drones, but you are going to keep referencing to the same class. And this, instead of you having to rewrite this code every time, you can end up, you just basically need to use this list as simple as this. So your code keeps clean, your code keeps dry. Remember, we talked about the concept of dry. Do not repeat yourself. Also, don't repeat yourself. And also, we have code reusability. Now, for example, if we have this drone, for example, and later, maybe the company we're working for has said, now I think we are not going to use drones anymore, but we are going to maybe deliver using, let me try to get, I got this picture somewhere. I think this is the picture. And we said maybe this time we are going to use these tankers, for example. You can use the same code that you used in your drone, okay? Borrow ideas like the camera, because we know it has a camera. Borrow the code of this, okay? And now maybe just code new parts, like maybe I don't know what these are called, those chains that be on those tankers, okay? So it gives you the concept of code reusability, all right? So that is why classes are very, very important, and you need to understand the concept of classes. But let's go back to our code here. So we have self, okay? So self is, we are saying it is referring to this drone that we are creating, but we are just merely giving it a name self here because we do not know what the people in the future or what object in the future will be created and which name will be given to it. So self is just basically referring to the object itself. I want to first confirm that we are together before I proceed. Are we understanding what I'm saying, guys?
Yeah, we're trying our best.
Okay. So, this self keyword is something that you go back and watch this video after we have uploaded it, and until you appreciate the self keyword, because sometimes it can be a concept that is tricky to understand in the beginning, but it is actually as simple as recognizing that self refers to the object itself, okay? So now we have attributes, and we see that we are using self.camera, self.propeller. So let me try to, if I run this code, let me remove this help, okay? We saw that when we try to run this code, it is going to tell us, run the code. Okay, so let's see what is invalid syntax. Line 1, do we have any issue in our code? Self camera propeller, self.camera is equal to camera, self.propeller. Try that, delivery 1, drone 1. Yeah, it should be working. Why don't we have this code? It could be, let me just copy this code and put it in my, I don't want to be troubleshooting VS Code.
In Jupyter, it has run. I don't know.
Yeah, it is just something that was happening with my VS Code, and I don't want to troubleshoot. We have little time left. So you see that we have something like this, but let me try to remove this self here, and let's also try to remove this self, and we just keep it. Camera is equal to camera, propeller is equal to propeller. So if we run that, you're going to see that we're going to get an error. It's going to tell us that delivery drone has no attribute of camera. What it is saying is our drone basically has no camera. Okay? How do you fix that? Tell the drone itself that you have created here, which is drone 1, tell it that please drone, okay? In your mind here, you're just basically saying that drone 1 dot camera, okay? But because you want to keep this code reusable, you just say self dot camera. And also here, you just say self dot propeller, okay? So when you run that, you basically get your code running very, very smoothly. So now, we have also something here, okay? This is a method that is under the drone. So basically we're saying maybe create a method called fly, and we see that we are using the word self here. We're passing in this same parameter, self, okay? Why do we use self? So let me try and print drone1 dot, okay, fly, okay, and try to run that. You see, it tells me I can fly and brings none. If you remember when we did functions, we said that if you're returning nothing, the function should return something. And if it does not return something, it's going to return a none type. But I want you to get this attention here that we are accessing the method I can fly by just saying drone1 dot fly. The same way we can say mylist dot append, mylist dot something, mylist dot delete, or all those methods that you can access. So we can also access methods that are within this class with just basically calling the method. So let me try to remove this self here, and you see. So it gives us a type error. Delivery drone fly takes 0 positional arguments, but 1 was given. Okay, so you always have to make sure that you call the word. You have to put the keyword self, because we said self refers to the object instance itself. Now, I want us to continue a bit here. When you look at our code, we have what they call class attributes. Okay, we see we have attributes here, but we have what they call class attributes. So class attributes is basically, let's say maybe if they, let's say maybe every drone that we're supposed to maybe produce is supposed to be maybe checked if it is okay, or maybe is safe, okay? And we say true. If the drone is safe, true. If the drone is safe, here we can come and put in an if function and say if, okay, if is safe, right? If is safe, so basically we're saying if is safe is true, okay? So if is safe, then assign these attributes. Add the camera and add the propeller. Make sure that you indent your code properly. So you notice that this word is at the same line as this, all right? You notice that it is at the same line because this is what we want to call it, a class, class object, okay? So let me try to do that. So now if we run this, oh boy, is safe is not defined, okay? So why is safe not defined? We are under this part. So the only way to solve that is, you see, is safe is not referring to anything here. So we have to put a self keyword somewhere. So it has to be a self dot is safe. Is that drone safe? Because we said self refers to the object, this object here, but we are basically giving it a name because it has not been created yet. So if drone is safe, then give all these attributes. And when you try to run that, you see that your thing will basically run. So why are we calling it a class attribute? So can I print something like, let me say, print delivery drone, okay? So let me try to say delivery drone, and we check if delivery drone is safe. Yeah, it is true because delivery drone is true, right? But let's try to print something like is delivery drone dot. Let's get one of the attributes here, like maybe print delivery drone dot camera. So if we try to print that, it's going to tell us that an attribute error, that the object delivery drone has no attribute camera. Why? Because we see delivery drone is a class name, and camera, whereas it is part of this class, but it is not a class object. It is within this constructor. And therefore, this being a class object, you can do something with it. Okay, you see we have done things like even give conditionals. Okay, and that is the power of what we call class objects. But this class object is it's unchangeable, or it is what we call static. Okay, it is not dynamic. As well as this camera and propeller are dynamic, that we can assign any drone these features. This part, which is safe, is going to remain constant. It is basically going to remain the same way it is throughout that code. Okay, so classes are very, very beautiful things. They help you keep your code dry. They help you keep your code reusable. They help you keep your code very easy to read, and you can keep on building on this class and build on that class and build on that class. Now, in this class, I didn't really want to pump you a lot with too much, especially that there's a lot to unpack with classes. But at this point, I'm going to take questions because I had no power at my place, so seated at some hotel. I want to run back home, so I'll take some questions, and then on Friday we shall have a Friday session and a Saturday session to compensate for the one we missed on Monday, because we want to wrap up this Python so that next week we actually start actual data science. So let me take some questions for those who have some questions, and then we'll take it from there on Friday. But I want you to read more on classes. Yes, someone asked me a question. Or if we have all understood, then it is okay.
So let me just let me ask.
Yes.
In this instance,
Mm.
self stands for the class delivery drone. Every time we put self, we are meaning delivery drone, right?
No. You're not meaning delivery drone. Delivery drone is the class name. Okay. So when we create a class name and we create this constructor method here, okay.
Okay.
You should create this constructor method here. The self keyword basically stands for the object that you'll create later. We say that the way you see lists, okay, the person who put the code behind lists, because we saw that lists are in a class, okay. So where was it? I had that code somewhere. Lists are in a class. Yes, here. So you see that we have class list, okay? So the person who wrote the code behind a list, they give the list methods, okay, that you can use whenever you write a list. And some of them have the dot reverse, okay? We have seen it in VS Code was giving us such things like, okay, so dot append, dot extend, dot clear, dot copy, dot what, yeah? But this person did not know that one day you'll create a list. Maybe we are seeing list comprehensions here, that you'll maybe create a list and call it my list 5. Okay. Now, to see substitute for that name, basically, what we are saying, to substitute for that name, you use the keyword self, okay? You use the keyword self. So self is basically standing in as a placeholder, okay? As a placeholder to stand for that, to mean the name of that object that you will later create. Now we are seeing that we have a class of a drone, but we don't know, maybe, I don't know if you know some brands of drones, maybe, I don't know, HD, I can try and Google maybe types of drones, maybe. We have, maybe you can call it a fixed wing, multi-rotor. Yeah, maybe you can call it a fixed wing drone, okay? So you don't know that one day you'll create a drone and call it fixed wing drone, okay? Maybe let's give it a proper variable name. So fixed wing drone. What am I doing here? Fixed wing drone, okay? So one day you create a drone and call it fixed wing drone, right? But when you're writing code, for you don't know that one day you will do that, okay? So, and you don't want to keep coming to this code to replace this with fixed wing drone, fixed wing drone dot propeller, dev fly, and then you put fixed wing drone here. Your code is not dry because you'll keep on writing the same code and replacing that name. But to stand in for that, we use the self keyword. The self keyword stands for that object that has not been created yet. Are you getting what I'm saying?
Yeah.
It's something that has not been created yet. So that later when you create it, you can use the attributes and the methods under that class. Like how we have seen, we create fixed wing drone, but we call the method delivery drone and we give it the same attributes that we had in our blueprint. Is that clear?
Yeah. So that now, does that mean that if you have a different type of drone, say we saw multi-rotor, and you've already run your code with fixed wing, does that mean that you just put multi-rotor and say is equal to delivery drone HD blah blah blah, and when you run you get the code HD for propellers?
HD, let's do it, and maybe multi-rotor. Let me say it has 10. I don't know if it has 10 rotors, for example. Now, if you come and now we have instantiated, okay? This is called instantiating. We have created an instance of the class delivery drone, okay? So now when I come and print out multi-rotor drone dot, you see it, I have access to these methods.
Okay.
The same way I had access in a list to the whatever comes after the dot. It should be making sense to someone, okay? And it's not really that complicated. So let me put a bracket here. So multi dot. Now if I say camera and I print out that, it is going to give me, I don't know why my VS Code is refusing. I'll troubleshoot it later, but let me run it from here. So what's wrong? Multifrost dot camera. Oh yeah. Dot camera. It tells me that the camera is an Ultra HD, and at the same time, I can maybe copy this code, paste it here, and say multi-rotor drone dot the propeller, and it's going to tell me there are 10 rotors, but we are using this multi-rotor. We can even create other drones as many as possible. and we just keep on passing in these arguments, but we have not touched this code. Do we get the concept of reusability now?
Yeah, I get it.
Okay, thank you very much. Another question.